Hello everybody, my name is Hassan Helmi. I'm the Assistant Vice President of Projects. I'm currently responsible for preparing the business plan for BIM implementation across projects offices. I've been the project manager for MBK project for the past 5 years, and we have initiated and managed the deployment of BIM on the MBK National Bank of Kuwait headquarters project during the pre-construction phase, and I'm overlooking the BIM implementation also during the construction phase. At the beginning, I would like to start with that there is no one single project would give us or realize all the benefits of the BIM. There are too many. This case study will document the use of parametric modeling first by the designer at early design stages. And this would give us an example of the collaborative workflow between the designer, the architects, and the engineers. And then later, BIM implementation in this project was initiated by the client, actually, by the owner. And it's one of the very few projects in Kuwait that have been started implementing BIM fully. I think it's the second or the third project in Kuwait. Contractors are taking the lead in Kuwaiti market for BIM implementation, but this is the first time the client, with the project manager, we advised and deployed the BIM implementation. We'll be presenting some case studies and benefits of clash detection, quantity takeoffs during the pre-design stage, pre-construction stage, followed by BIM implementation during construction phase by the contractor. Issues of interoperability, BIM implementations will be discussed. This case study discusses how the owner and the PM initiated the BIM effort on the NBK project and how this was integrated into the design and construction phases of the project. And I need to highlight that when we implemented the BIM on this project, the design was already at the design development stage. It was too late in the design process. The case study will highlight some of the benefits, how parametric modeling can manage design changes, inefficiencies of traditional practices. Here I refer to the traditional interdisciplinary coordination review using CAD layers that we used to do, radio check systems, and the BIM implementation challenges, being the first time for the contractor to use BIM on complex project, and finally, lessons learned. The project is in progress at the time of writing this case study, preventing a full review or complete assessment of the benefits. We're about 20% progress on site. The project is fast-tracked. That's why you can see the design is only at 80% because we're remaining the finishes package and the FF&E works to be released for tender. The case study will be divided into 4 parts. Project overview, to give you an idea about the project, BIM implementation process among the phases of the project, then evaluation and lessons learned, and conclusion. We'll start with the project overview. The project is for the National Bank of Kuwait new headquarters, located in Kuwait. Construction cost is $400 million US, of built-up area 130,000 meters squared. The project delivery method, as I mentioned, is multi-packaging and fast track. The project is targeting Gold LEED certificate. The owner is MBK. Projects were the project managers on the project, in addition to being the cost consultant and the lead administration management consultant as well. The architect is Foster & Partners, London office. The engineer responsible for the structural works and the MEP works, Rappled, London office. The BIM consultant, BIMS. The contractor is Ahmadiyya Contractor and Trading. The project is a high-rise building of 300 meter high with around 3,500 employees utilizing this space. As you can see, one of the driving factors to implement BIM in this job was this complex geometry. The towers shaped like a shell, the tapering to at the top. This iconic structure, complex geometry, was a challenge to us. Let me play a quick animation prepared by Foster & Partners on the project, only 2 minutes, to give you an idea about the project. Because the project is LEED certified, we're targeting LEED. Energy analysis and sustainability was very important to us. The fin design, The tower is 300 meters high, next to the Al Hamra Tower, the tallest tower in Kuwait, 400 meters. Iconic structure, complex geometry. This shows the beginning of the BIM, the 3D animation, visualization of the design by the client, and how this helped in the selecting the best options for the client. As you can see, the complex geometry was one of the driving forces that let us implement BIM on this project. The story starts from the early concept design stages. Foster and partners in Buraku, they utilized parametric modeling approach. It was late until the design development stage when the owner and the project manager decided to implement BIM. We'll start with the parametric modeling. It's a fundamental technology behind BIM. And in this case study, we'll present how the architects developed a collaborative workflow centered about BIM modeling and how this helped and to interact between the architects and the engineers. Parametric modeling approach meant that the geometric configuration of the office tower could be numerically controlled, removing the need to manually edit or rebuild the geometry when a change occurred. The project was subject to various changes during the life cycle of the design phase. And the architects would like to control any changes in the geometry, especially of the external geometry of the envelope's facade. So there was a hypothetical boundary surface was discussed that separated the domain of engineering responsibility from that of the architects. This geometry of this hypothetical interface layer was controlled by the architects and passed to the engineers. This diagram tries to illustrate how the modeling rules built in the parametric model help that if any changes affect the architectural skin, will automatically be corrected and adjusted in the structural. Parametric modeling is great in testing and generating alternatives. The architects have developed hundreds of models of different forms. There was, as Martin mentioned, the collaboration and teaming, the stakeholders' involvement in the project. This is a photo of one of our workshops in London office at Foster and Partners, where we can explore options and the client is part of the story and decision making. The pre-tender stage. As I mentioned, our role as projects were the project managers, construction managers, cost consultant, lead administration management for the project. One of our services was to perform interdisciplinary coordination review. And we were facing some challenges in reviewing this iconic structure with this complex geometry. The way how we used to do it was using CAD layers, overlaying, using ready check system, and it was good in the old days, but nowadays with these complex iconic structures and innovation of the designers, it proved to be inefficient. So we need to find a solution. And to us, the solution was implementing BIM on the project. Unfortunately, the BIM was not under the scope of work of the architects and engineers, so we thought of hiring a third-party BIM consultant on the job. As this had helped the project, it added some complexities, adding new player to the team. So it was until the end of the design development stage where we decided to appoint a BIM consultant on the job. So we had the designer having his 2D CAD drawings and the parametric modeling, and now we hired a BIM consultant. We signed an agreement on June 2012 based on AIA document E202. And we requested the BIM consultant to develop the model to LOD 300. As you know, the BIM level of the development, similar to the traditional project delivery methods, LOD 100, it's the equivalent of concept design until we reach the LOD 500. So we asked the BIM consultant to develop a model of level LOD 300, and then later we wanted the contractor to develop a model, construction BIM model, LOD 500 as built, to be used for facility management by the client at a later stage. Our targets. The first was discovery of design errors and omissions before construction, clash detection. This was the main reason why we implemented BIM in the job. Automatic corrections when changes are made to the design, because the project design was subject to various changes. Generation of accurate and consistent 2D drawings at any stage, design, construction. Also, we used BIM for auto-generating bills of quantities for the project. But our main target was full implementation during construction phase, utilizing 4D and 5D and using it for facility management. The project is LEED certified. What we missed because of the late implementation, we did not use the BIM from early on, so green BIM was an opportunity. The intent was to develop a BIM model during the design phase that the information content could be passed during the tender, construction, and finally to the facility management phase. So the workflows, the designer have provided the BIM consultant with the 2D CAD drawings. And the BIM consultant from these 2D CAD drawings has to develop the 3D BIM model. There was some issues at the beginning of sharing the parametric model with the BIM consultants. And this is one of the conclusions that come at the end is the cultural change. We need to change the way we think nowadays in the construction industry. We need to collaborate more, and partnering is very important. The first model prepared by the BIM consultant using ArchiCAD and Tekla software, he developed two separate BIM models, was based on the 2 CAD drawings delivered by the architects. The first versions of the BIM model prepared by the BIM consultant were unexpected. This is not the form what we have presented to the client at the early stages by the architect. There was no problem in the architectural drawings, for sure. The BIM consultant is professional, so there was a problem, and we need to solve and figure out what have been done wrong. We conducted a series of meetings in Kuwait and in London trying to find out the problem. We discussed the geometry method statement, the GMS drawings in 2D, and we fixed the problem. And at the end, we have 40 drawing sheets only explaining the geometry of the tower, set of coordinates, some parametric rules, and this have been passed to the contractors and subcontractors. For the fins, every part of the project had its own GMS. But finally, we managed to get the geometry desired at the end of the day, like these images represent. This is an image of the BIM model using Tekla. So as I mentioned, the BIM consultant developed 2 models, one on ArchiCAD, one on Tekla for the structural works. So the main benefit was clash detection. Initially, we're performing design reviews using 2D. Now we turned into full 3D clash detection process. We have discovered several number of clashes and errors were identified and managed before tendering and construction. Some examples of the ArchiCAD BIM model: coordination between steelworks, HVACs, clashes detected, chilled water pipes crossing with steel members. We have reviewed extensively the steel structure. Again, the BIM consultant was using the 2D CAD drawings, and once he drew the model, there was some corrections that needs to be made to the 2D drawings and the calculation sheets of the structural quantities. Again, MEP, concrete, clashes detected and reported. The beauty about the BIM that it auto-generate clashes list, and then it will be issued in technical queries to the consultants, the architects and engineers. They will respond to that. Some of these issues were mistakenly perceived by the BIM consultant. The architect highlight his point of view, and then at the end of the day, we managed to solve most of the problems and the issues and the clashes during the design stage. So we believe that we have managed a substantial cost savings as a result of this. But after listening to Martin this morning, I think we need to quantify exactly how much we have saved by doing the BIM and implementing BIM during construction. Realizing the benefits of BIM in clash detection, we said let's go and automatically generate the bills of quantity since we have already the model. And we did, especially for the structural steel works. And we compared this with our manually prepared bills of quantities, and it proved to be a very valuable tool. In the tender phase, we asked the bidders to prepare an animated method statement. So this was part of the specifications, and we asked them to submit to us logistics plan, construction plan, typical construction cycle, animated construction sequence, and alternate proposals. And I will be showing you one of the bidders' submittal, showing 4D by Samsung. Logistics plan. By this, we could see everything virtually before beginning the construction works. a complete method statement in 3D and 4D. Animated construction sequence. The bidder submitted alternate proposals as well in 3D. That's proposing alternate structural system and reduced quantities and cost, of course. And with this alternate proposal, he can reduce the construction cycle by 2 months. When we first tried to convince the owner to implement BIM, there was some resistance. It would cost, how much would it cost? But after seeing this, during the tender stage, he was more convinced and he was more willing to complete with the BIM implementation during construction, actually to the fullest extent possible. So what complicated the problem, at the beginning, we had the 2D and parametric model. We had the design BIM model prepared by a third-party BIM consultant. And then now we're having construction BIM model prepared by the contractor during construction stage. One of the main challenges for the project team, especially the contractor, was utilizing BIM for the first time on a large complex project, was transitioning from 2D CAD environment to 3D. We're not in the same situation as the States. The examples presented by Martin. In Kuwait, where this is the early stages of BIM implementation, and most of the contractors did not implement BIM yet in Kuwait. So this was one of the major challenges. One of the first questions asked by BIM users for the first time, which software to use. We believe this is not the issue, whether being Bentley, ArchiCAD, Revit, or others. Critical lessons learned is choose the software appropriate for your project and your type of business or business goals of your organization. This is what matters. While BIM offers new methods for collaboration, it introduces other issues with respect to the development of effective teams. Again, it's all about collaboration, and the mindset in the construction industry of owners, contractors, designers has to be changed. The members of the project team were using different modeling tools. The parametric model by the architects were using Bentley, the BIM consultant used ArchiCAD and Tekla, and the contractor decided to use Revit. So the issue was sharing of the model information. How can we build from the effort and the rich model data that have been developed during the design stage? How can we pass this and the contractor can use it and not start from scratch in the construction stage? So this triangle of the BIM consultant, the design BIM model, and the parametric modeling of the architect who control the geometry of the building and everything else, and the construction BIM model. So as you can see inside the triangle, we have some implementation issues, the software, different modeling tools, the sharing of model information. But what's more important is the collaboration and challenges with the collaboration and teaming of the team members. So this is the bigger issue, we believe. It's not technical. One of the technical issues is the use of the IFC, Industry Foundation class, that allowed us to transfer the data from the ArchiCAD to the Autodesk Revit. Another issue was the misperceptions of some of the clients or new users of BIM, that in their mind they believe that it should be one single model on one single data file located in physically one single location. when the owner shared this with the contractor and the experts in the field, we said, no, we need to develop a composite building model. Parallel building models by the subcontractors and trade contractors, and at the end it should be composite into one building model. Parallel models versus single model. The contractor took the design BIM model from the BIM consultant on ArchiCAD, and he would develop his own concrete model in-house using Revit. The steel model will be prepared by his steel subcontractor using Revit as well. And the rest of the trades, the glazing will be by Revit as well. The fins, the subcontractor decided to use digital project. And the MEP's contractors will use Revit. What's more important, it's not the softwares. What we care about is the information exchange plan. How can the information be exchanged between these models? And then the model coordination plan. How could these be integrated into one composite model at the end to be delivered to the owner to be used during the facility management stage? The idea of parallel models or creating a separate model for the use of the contractor, of course it helps the contractor greatly, but it has to be reviewed to ensure that the design intent is maintained. That's why these are images from the construction BIM model generated by the contractor and commented by the architects and engineers on 3D. So these are the comments that are being passed back to the contractor to revise and resubmit. The contractor is asked to submit a BIM execution plan, explains how the 3D modeling protocol, 4D modeling protocol. What we care more about is the model quality control and the BIM trade coordination protocol in order to reach the as-built modeling, LOD 500. The contractor, according to the project specification, is required to submit and deliver site utilization planning using BIM model, 3D coordination for detecting flashes before generating shop drawings. That has to be generated automatically from the BIM model. We're not allowing 2D drawings. 4D scheduling, phasing and construction sequencing, similar to the video that I presented a minute ago. 5D costing, any changes in cost, how can we need to see the effect of that on the model. And finally, as-built model. Unfortunately, as of writing this case study, the construction phase is not yet complete. So it's impossible to quantify all of the benefits or even problems. But at this point, it's possible to say that there have been significant savings in cost and time resulting from reduction in design errors found by clash detection during design, and we anticipate the same during construction. Evaluation and lessons learned. Parametric modeling is a fundamental technology behind BIM. Benefits of BIM, I'll just go, this is a summary and then I will go one by one. Start BIM early, important lessons because we were late in implementing BIM and we believe we have lost some chances and opportunities. Parallel versus single model, interoperability, exchange of data, collaboration, not litigation. Parametric modeling is a fundamental technology behind BIM. I believe this is how BIM started, is with parametric modeling. Many advantages. Out of these advantages, we believe collaboration between the architects and engineers and the rest of the team wouldn't have been possible except with using parametric modeling techniques. The flexibility of the parametric model, I believe nowadays this parametric model will be transferred to the subcontractors and fabricators to be used during construction phase. The benefits of BIM are endless, starting with 3D, earlier and more accurate visualization of a design, early evaluation of design alternatives. We can produce hundreds and thousands of alternatives. Clash detection, early collaboration of multiple design disciplines, automatic corrections when changes occurs, and this is very, very important to complex projects. Clash detection, this was the main driver for implementing BIM in our project. 5D, extracting accurate bills of quantities, auto-generated from the model. All of this we have been using and we have been experiencing its benefits. 4D, synchronization of design and construction planning. Other benefits, green BIM. Our project is Gold LEED certified, targeting Gold LEED certified. So I believe there is a lot of opportunities during the construction phase. Improvement of energy efficiency and sustainability. This what we a little bit have missed during the design stage. But we can implement some lean construction techniques, because there's points on this and the contractor is obliged to work on that. Off-site fabrication. The curtain wall contractor will be using the model for off-site fabrication of some members. And at the end, facility management, integration with facility management and operating system by the client. Start BIM early. I think we missed some opportunities by the late start of BIM, so we recommend to implement BIM as early as possible. It's a great tool and resource that if it had been implemented earlier, would have gained more. Parallel versus single model. Some of the clients have misperceptions about the BIM, even till today. What's BIM? How it works? So we need to educate, and we as project managers, advisors to our clients, we are proud that we have implemented the BIM on this complex project, and we try to clarify some of the misperceptions in the market. Parallel modeling is great to have as far as we can link and import models together to create a composite model. And we believe that the trend in software development is going in this way. Interoperability, the ability to exchange data between applications is very important. The use of IFC and other techniques is very, very important. Collaboration, not litigation. I think my message today is collaboration. We need to change the way how we think in the construction industry. We need to collaborate more together. The business climate has to be changed into a more collaborative environment. And this starts from the way or the time we write our contracts and negotiate contracts at the early stages of the project. My conclusion at the end, BIM is a great technology and resource that will continue to grow and change our construction industry for the better. Nonetheless, BIM implementation to succeed must be accompanied by cultural transformation. The owner, project managers, designers, contractors, fabricators, facility managers, they need to collaborate together. These boundaries of legal concerns, model sharing, information issues, and this was really, we spent more time on these aspects, more than the technical aspects of the BIM itself implementation. It's easy to get the BIM software, to get trained on the softwares and implementing it, but the other cultural issues, I think it's very, very important in our business. Thank you.